Welcome our students. Today we will talk about the second lesson in the geometry for the third year for the preparatory stage. This lesson is talking about the position of a point and a straight line with respect to a circle. Firstly, we will start with the position of a point with respect to a given circle. Here we have three cases for the point related to a circle. Firstly, if we have the point A is outside circle M, like here in this circle, we will find that if the point lies outside the circle, so MA will be longer than the radius length. We know that the radius length starts from M and moving till it will reach here. This distance is called radius, but the distance MA is longer than the radius because it has a more length here, so MA will be greater than the radius length. Secondly, if we have the point A on the circle M, so we will find that the distance between the point A and point M will be equal to the radius length. The third relation, if we have the point A inside the circle M, like here, we will notice that if the point M here, which is the center of the circle, so the distance between M and the point A is shorter than any radius inside this circle, like here. So MA will be smaller than the radius length. So we have known now the three relations between the point A and circle M in different positions: outside the circle, on the circle, inside the circle. We will go for the second relations between the circle and a straight line. Now we will talk about the positions or different positions of a straight line with respect to a circle. We will notice that the first case, if MA greater than the radius length, we will find that the straight line L outside the circle M, like here. We have the circle M, the point A belongs to the straight line L, and this line is outside the circle. We notice that the radius length will be starts from M up to this distance, and the point A is outside the circle, so MA is greater than the radius length. We will notice that the straight line L intersects the circle M equals phi. This notes is very important because it comes for a complete or choose questions. Really, this straight line doesn't intersect with the circle M, so the intersection with them is equals to phi. The second note in this case, that the straight line L intersects the surface of circle M equals phi. Now the question will be, what is the difference between the intersection with circle M and the surface of circle M? We will notice that the circle M is here. That's called is circle M. But if we are talking about the surface of circle M, it will be here. That will be the surface of circle M. It is the inside part inside the circle. We will notice that there is no difference between the circle and surface of circle in this case, because the line is already outside the circle. So the intersection between the straight line and the surface of circle M has no difference. The result is equals to phi. The second case that we will talk about will be if MA equals the radius length. That means that the point A here lies on the circle. It lies on the circle, and the straight line is called a tangent. This word is very important, and it will face us in following lessons. The straight line, if touched the circle at a point which is here, the point A, so the straight line here is called a tangent. The straight line is called a tangent if it touched the circle at one point. The straight line is a tangent to the circle M at the point A, and the point A is called point of tangency. Point of tangency, that means that the point A is the point which the line touches the circle M at it. The circle M and the straight line touched each other at the point A, and we will notice that the straight line L intersects the circle M at the point A, written like here. The second note that the straight line L intersects the surface of circle M at also the point A. We notice that there is a perpendicular sign between the straight line L and the circle M at the point of tangency. So we must know that the tangent is perpendicular like here, the straight line L is perpendicular with the radius at the point of tangency. The third case we have for the relations between the straight line and the circle M, if the distance MA is less than the radius length. Here in this circle we notice that the straight line L is a secant. This is a secant definition we have in this lesson. Secant. What is the secant to the circle M? If the straight line passes inside the circle. If the straight line passes inside the circle, it will be called a secant. And we must know that if the straight line passes through the center like here, In this case, this straight line will be called axis of symmetry. But the straight line, if passes through any position like here inside the circle, it will be called a secant. The notes we have in this case that the straight line L intersects the circle M at two points, which are X and Y. We have the straight line intersects the circle M at 2 points. The first point is called X, the second point is called Y, and the second note we have here that the straight line L intersects the surface of circle M at the line segment XY. We will find that we have a line segment here XY. This line segment is passing inside the circle, so the difference between the first note and the second note, that the straight line intersects with the circle M, and we talked about this point previously in the first and second case, that the straight line intersects the circle M with the outer points of the circle only as a frame, but the straight line intersects the surface of circle M, and the word surface is very important because we will find that the word surface is here, all the area inside the circle, so the intersection here at this point or this line, like here. This line segment is called XY. It is an intersection between the straight line and surface of circle M, where XY here is called a chord of intersection. So now we have finished talking about the position of a point and a straight line with respect to a circle. Now we will study some important facts. The first is the tangent to a circle is perpendicular to the radius drawn from the point of tangency. We have here we have in this circle the first fact that the tangent, which is the straight line L, is perpendicular, and this word is very important because it comes as a complete or choose, is perpendicular with the radius, which is MA, from the point of tangency at the point A. So the straight line L makes a right angle with the radius length, or the radius with at the point of tangency. We have in the second fact here the straight line which is perpendicular to the diameter of a circle at one of its endpoints is tangent to the circle. We have AB perpendicular to the straight line L at the point B. If we looked at the figure here, we will notice that the straight line L is perpendicular to the diameter of the circle M at one of its endpoints, which is the point B, like here. And we notice that the point B is point of tangency. So the straight line, if it touches the circle at one point, it will be called a tangent, and it will be perpendicular with the diameter or the radius at the point of tangency. The third fact we have in this lesson the two tangents which are drawn from the two endpoints of a diameter of a circle are parallel. In the second fact, we talked that the straight line L is perpendicular to the diameter AB at the point B, which is one of its endpoints of the diameter. Also, we have another straight line K is perpendicular at the point A, which is the point of tangency with the diameter AB. What is the relation here between the two parallel or the two straight lines L and K? We will find that the two straight lines L and K are parallel. So L and K, the straight lines, of two tangents at the points B and A respectively. So L will be parallel to the straight line K. And now we have finished all the facts about this lesson. Now we will start with the first example here. In this figure we have BC is a tangent at the point B. Measure angle C equals to 45 degree. D is the midpoint of AH. The required to prove that DA equals DM. We'll see the figure now. BC is a tangent at B. Measure angle C equals 45 degree. D is the midpoint of AH. That's mean MD bisects AH at the point D. The required to prove that DA equals DM. How to prove that we will see now. The first step in the proof. In this problem, since BC is tangent to circle M at B. Therefore BC is perpendicular to AB. That's mean the measure angle of B here equals 90 degree. Therefore in triangle ABC, measure angle A equals 180 minus 90 plus 45 equals 45 degree. The 90 degree for angle B, the 45 for the angle C. We have in the triangle ABC, like here, measure angle C 45, measure angle B equals 90, so the measure angle here will be equal to 45, and this step will be numbered as 1. We will continue our proof by since MD is the radius and D is midpoint of AH, therefore the measure angle here will be equals to 90. We are talking inside the triangle ADM. Therefore measure angle ADM equals 90 degree. Therefore in triangle ADM, measure angle AMD equals 180 minus 90 plus 45 also equals 45 degree. So the measure angle here will be equal 45 degree. Now we have in the triangle ADM measure angle M equals 45, measure angle A equals 45. So the two sides AD and DM will be equal because this triangle will be an isosceles triangle. We will write that now. Therefore measure angle A equal measure angle, before that we write from 1 and 2, measure angle A equal measure angle AMD equals 45 degree. Therefore triangle AMD is an isosceles triangle. Therefore DA will be equals to DM, and that is the required to prove. Now we'll go to another example and try to solve it. In this example we have AB is a diameter in the circle M, AC is a tangent to the circle at A, measure angle DMB equals 100 degree. We have two equals to find or to prove. The first, that measure angle AMB, and the second, we have to find measure angle CDM. We will go to the figure and see that we have here measure angle DMB equals 100 degree. We know that MD and MB will be two radii in the circle, and they must be equal in measure. We will start our proof by this point. Since MD and MB are two radii, in circle M, therefore MD equals MB. In triangle DMB, we will find that measure angle B equals measure angle MDB equals 180 minus 100 over 2 equals 40 degree. So now we know that the measure here equals 40 and the measure here equals 40 degree. And this will be number 1. If we go to the figure now, we know that AC is a tangent to the circle at the point A, so the angle here must be equals 90 degree. Now we have in triangle ACB, the big triangle, measure angle A equals 90, measure angle B equals 40 degree. So by calculation we will find that measure angle C or angle ACB, which is the first required, equals 50 degree. And the second required was to find measure angle CDM. We have here a quadrilateral which is CAMD. We have here angle C equals 50, measure angle A equals 90 degree, and by subtracting from 180 we will find that measure angle AMD equals 80 degree. So by calculation the remainder here is 140 minus by subtracting from 360. There are another easy solution, which is for a line segment here BC. Since measure angle MDB equals 40 degree, so by subtracting from 180 the result will be equals 140 degree, which is the measure of CDM. Now we will write that. Prove in triangle ABC, measure angle ACB will be equal 180 minus 90 plus 40 equals 50 degree, and that is the first required. To find the second required, which is the measure of CDM, since CB is line segment, and D belongs to the line segment CB, since measure angle MDB equals 40 degree, therefore measure angle CDM by subtracting from 180 will be equal 140 degree, and that was required. I hope that you have understand this lesson from me, and I will see you in the next videos for the geometry and algebra of the third year prep. Goodbye.